Hi, everybody. Welcome back to section 5.2. We're going to be covering the rest of example 2, U substitution. So we have here example F, the integral of 16x plus 10, e to the 4x squared plus 5x. And what we're going to do is let u equal this exponent 4x squared plus 5x. So let's go ahead and write that out. So let u equals 4x squared plus 5x. We're going to take the derivative of this expression. So this would be 8x plus 5 dx. And then I'm going to move everything over to the left side to get dx by itself. So this would be dx equals du over 8x plus 5. So I'm going to take my u and my du over 8x plus 5 and plug that back into my integral. So this integral would equal 16x plus 10 e to the u times du over 8x plus 5. So once again, we don't have a clear cancellation, but what I can do is factor out a 2 to be able to cancel out 8x plus 5. So let's go ahead and take care of that. So this would be 2 8x plus 5 e to the u times du over 8x plus 5. And so now we can cancel out 8x plus 5. And what we're left with is the integral of 2 e to the u du. And now we just have a really simple integral. So this will just be 2 e to the u, the same exact answer, because the integral of e to u is just itself, and plug back in what our u equals to get it in terms of x. So e to the 4x squared plus 5x plus c. And that is my final answer. Okay, so let's go ahead and check out letter G. The letter G is the integral going from 4 to 8 of 5 over x minus 2. So this is a definite integral now, since we have a lower and upper limit. So we're going to do the same substitution as we would. So I'm going to let u be that denominator, x minus 2. I'm going to let du equal the derivative of x minus 2, which is going to be 1 dx. So basically du just equals dx, and we don't have to substitute in too much for dx. So let's go ahead and take care of this integral now. Go ahead and close off our previous problem. But let's go ahead and have this integral. So we're going to have the integral from 4 to 8. The 5 stays the same, but it'll be over u, and dx just equals du. Okay, so just to make this a little easier to see, 4 to 8, 5 times 1 over u du. And the integral of 1 over u is just going to be the natural log of u. So this would be 5 natural log of u. And we have a lower and upper limit, so there's no plus c. So what I'm going to write is our same upper and lower limit. So I'm really emphasizing the x equals 4 and x equals 8 because we can't plug in 4 and 8 right now because it's still in terms of u. I can't plug x equals And for u, it would need to be u equals. So I need to change this back into x before I can plug in these x limits. So what's my x or what's my u again? It's going to be x minus 2. So let's go ahead and change it back to 5 natural log of x minus 2, going from x equals 4 to x equals 8. And now I can solve this definite integral. So this would end up being, coming over to the left a bit, this would be 5 natural log of 8 minus 2 minus 5. Scoot this down a bit. 5 natural log of 4 minus 2. And we can just evaluate this. So what we have is 5 natural log of 6 minus 2. Excuse me, 6 minus 5 natural log of 2. And so we can get rid of the absolute values since we know they're positive already. And so 5 natural log of 6 minus 5 natural log of 2 would be approximately 5.49. Okay, so that would be the answer for this definite integral. And remember, for definite integrals, we get an actual numerical value. So that's when we have a lower and upper limit. So that's substitution with actual limits. Okay, so let's go check out another example. Let's go ahead and look at letter H. So letter H is the integral of e to the 5x going from 0 to natural log of e. So don't be too scared about this. Natural log of e, that's just a number. Okay, it's not like a function, it's just an actual number. So same thing previously, we need to pick a u, and u is just going to be this exponent 5x. So we'll say let u equal 5x and du equal 5 dx. Okay, so want to get dx by itself, so divide 5 to both sides. So we have u equal 5x and dx equal du over 5. And so we're going to plug back into this integral here. So we'll have the integral from 0 to natural log of e to the u, and then du over 5. Let me rewrite this again to make our integral a little easier to see. So 0 to natural log of e to the u over 5 du. So then the integral of e to the u over 5 is just going to be itself. So e to the u over 5 going from 0 x equals 0 to x equals natural log of e. Okay, so once again, these are x limits, and this is a u, and we can't plug that into u. So we need to write it back in terms of x. So our u equals 5x, so I need to put back in 5x. So this is e to the 5x over 5, going from x equals 0 to x equals natural log of e. Okay, so let's go ahead and solve this integral. So last step is e to the 5, plugging in our limits, minus e to the 5 times 0 over 5. And let me show you really quick that ln, what ln of natural log of e equals. So let's go ahead and go to Desmos. I have natural log of e is just going to equal 1. It's just a number. So let me come back to our notes and note that natural log of e just equals 1. So I have here e 5 times 1 over 5 minus e to the 5 times 0 over 5. And this is just e to the 5 over 5, e to the 0 over 5, and e to the 0 is just going to be 1. Let me show you that as well. So e to the 0 is just going to equal 1. Okay, so almost done. What we have for our final answer is e to the 5 over 5 minus 1 over 5. And that will give you a numerical answer, but it's okay to leave it exact like such. Okay, so that's example H, another definite integral. Let me close this off as well. And let's go ahead and look at one more example. So we have the integral of 3 over 5 minus x going from 2 to 4. And we want to integrate this. So what we'll have chosen u to be is that denominator 5 minus x. So let u equal 5 minus x. Have to take the derivative of u. So this would just be negative 1 dx. Because of the negative x, there's an invisible 1 right there. And so we want to get dx by itself. So this would be negative du equals dx. Okay, so we want to substitute these back into our integral. So this would be the integral of 2 to 4, 3 over u times negative du. Okay, so I want to clean this up a bit. So what I want to do is take out this 3. We can make it a negative 3 and just take it outside the integral to clean up our integral a bit. So we'll have negative 3, 2 to 4, 1 over u du. And now we just have a straightforward integral. So the integral 1 over u is just natural log of u. So this is negative 3 natural log absolute value of u going from x equals 2 to x equals 4. Okay, so last thing I want to do is plug in what u equals so I can plug in my upper and lower limits. So coming back up here, I'll have natural log or negative 3 natural absolute value of what's u equal 5 minus x. So I'm going to plug in 5 minus x and I'm evaluating from x equals 2 and x equals 4. So now I can plug in my lower and upper limits. So this would equal negative 3 natural log of 5 minus 4 minus negative 3 natural log of 5 minus 2. And so this would be negative 3 natural log of 1 plus 3 natural log of 3. And so since we know that 1 and 3 are already positive, we can take out the absolute values. And so natural log of 1, let me show you on Desmos what that will always be. So natural log of 1 is always going to be 0. That's a easy identity to know. Saves you a couple steps of work if you know it already. So this would just be negative 3 times 0 plus 3 natural log of 3. And so we just have 3 natural log of 3, which is approximately 3 natural log of 3 is approximately 3.296. Okay, so that is our definite integral. So this 5.2 section was all about substitution, and we did plenty of examples using substitution. And I hope it makes sense, the process of it. It's the same process over and over again. Just the hardest part is identifying what you pick for you. But hopefully you saw the pattern of how to choose you for all these examples. But that's it for this video, and I'll see you next time. Thank you. Bye.